Okay, so this is from Thursday's lesson. You don't need to worry about 29 through 34. These we had done previous days. 37 through 42 is where we're just going to focus our time. Actually, 37 through 42 don't worry about. We'll worry about 46 through 52, which is graphing. So an example of the problem they might ask you is, for example, graph y is equal to log base 3 of x. So the question is, what does this graph look like? The best way to do this is actually to rearrange it in exponential form. So if you remember, this was the exponent, or this was the base, this was the exponent, and this was the answer. Okay, so in exponential form, this would be 3 to the y equals x. Okay. What I'm going to do is create an xy chart, but here's the difference. Instead of plugging in for x, I'm going to plug in for y. So I'm just going to pick the points -1, 0, 1, and 2 should be far enough for now. Okay, if I plug in -1, it's 3 to the -1, which is 1/3. If I plug in 0, 3 to the 0 is 1. If I plug in 1, 3 to the 1 is 3. And if I plug in 2, 3 to the second is 9. Okay? So let's see what the graph looks like. I'm going to pause it and make an XY graph. Okay, here's the XY graph. So let's just plot the points. I'm going to go ahead and plot 1/3, -1, which is about there. Let me change the color. 1/3, -1 is about there. I got 1, 0, which is going to be an important point, which is right there. 3, 1. And then finally 9, 2. So if you graph it, the graph will actually look something like this. Okay, I kind of missed that point. We'll just move it down. Okay, and keep in mind, as with exponential, there's an asymptote here at x equal to 0. Okay, so that is our basic logarithmic graph. They all look like this. So now what we can do is we can just put some more problems. But we're just going to change things a little. So for example, if I have log base 3 of x plus 2, okay, exactly what you would expect to happen is everything on this graph, okay, would just move over because of that plus 2. This would move 2 to the left. So picture the entire graph, and I'm going to grab this point here at 0, 1, just moving 1, 2 to the left. Okay? Okay, let's reset it. So let's say now the problem asked instead, I'm going to choose a different color here. Let's say problem 2 is y is equal to log base 3 x plus 1, or let's go x minus 1 plus 2. Okay, so this one would move it 1 to the right, and the 2 would move it 2 up. Okay, so literally, like before, I'm just going to take this graph, I'm going to move it over, I'm going to grab this point right here, I'm going to move it over 1 to the right. Okay, I took too much, forget it. So let's just graph it. So I'm going to move it over 1 to the right and 2 up. So I'm going to move the asymptote first. The asymptote is going to move 1 to the right. So it's now x equal to 1. Okay, and moving it up doesn't really do anything. So I'll move this point here 1 to the right and 2 up. It's going to go like this, so the graph should look like it's shifted over a little bit, like that. Okay, there's still the question of domain and range. If you look at this, the domain, the furthest left I could go is here at x equal 1, the furthest right is forever, so the domain is x is greater than 1. The range I could go as low or as high as I want, so the range is all real numbers. I'm going to clear the graph. The actual question might be, well, what would happen if it wasn't 3? What if it was, so we'll call this problem number 3. What if it was log base 4 of x? Well, again, the shape is the same. They all pass through this point 1, 0, but log base 4 of x would actually look exactly the same, except for it actually would not grow as steeply as log base 3.